Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acetanilide is formed by acylation of the amine group of aniline, NH2, with an acetyl group, CH3CO, producing PHNHCOCH3. The reagent must be capable of transferring an acetyl group to the amine, i.e., it must be an acylating agent. Moving on to the next step. Evaluate option A, acetyl chloride, CH3COCl. Acid chlorides are highly reactive acylating agents. Aniline reacts readily with acetyl chloride to give acetanilide. This works. Moving on to the next step. Evaluate option B, acetic anhydride, CH3COOCH3. Acid anhydrides are well-known acylating agents. Aniline reacts with acetic anhydride to give acetanilide. This works. And for the final step, evaluate option C, acetaldehyde, CH3CHO. Acetaldehyde is an aldehyde, not an acylating agent. Reaction of aniline with acetaldehyde does not yield acetanilide, instead it can form a Schiff base, imine, PHN is equal to CHCH3, via nucleophilic addition elimination, but no acyl transfer occurs. An aldehyde lacks the leaving group necessary for acylation of the amine to produce an amide. Therefore, acetaldehyde does not react with aniline to give acetanilide. Evaluate option D, phenyl acetate, PHOCOCH3. Esters of phenol are reactive acylating agents toward amines, aminolysis. Aniline can displace the phenoxy group to give acetanilide. This works. Why option C fails? Acetaldehyde, CH3CHO, does not have an acyl leaving group. It undergoes nucleophilic addition with aniline to form an imine, Schiff base, not an amide. The carbonyl carbon in an aldehyde has a hydrogen as the leaving group position, which does not facilitate amide, acetanilide, formation. Therefore, the correct answer is C. Therefore, the correct answer is option C.